Okay, so the topic that we'll be doing today is pH titration curves. For that, the first two things that we must understand is the equivalence point and the end point. Equivalence point is basically the point when we have two quantities in equal molar amount so that one reacts completely with the other. Right now, we are focused on acid and alkali because we are focused on the pH titration curves. That is why I've referred to acid or alkali. The end point is specifically the point when your indicator changes color. So be clear about using these terminologies and understanding these concepts. Now let's have a look at a few of the titration curves that we'll be doing. Okay, I've taken a strong acid, hydrochloric acid in the flask, and I'll be dropping a strong base, sodium hydroxide, from the burette into the flask. Let's see how our pH changes and how our indicator changes color. We're adding it dropwise and you will see the pH rising. The pH was initially very low because the solution in the flask was acidic. And the burette is where the alkali is coming from. And we see this is the equivalence point. So the equivalence point is the point when both are in equal quantity. And we want to know this point while we are performing the titration. So did our indicator change color at the equivalence point? That is the ideal thing. We want our indicator to change color at the equivalence point so that we can identify the equivalence point. When we are doing titration in the lab, we cannot identify equivalence point just with the naked eye. We need the indicator to tell us when we have reached the equivalence point. If I would have done the same thing with methyl orange as an indicator, the same titration, let's see what would have happened. See, methyl orange is initially orange or red in color because the solution is acidic. What happens when I start pouring in an alkali in this one? The pH change will obviously be the same. And the methyl orange will still be orange or dark orange in color. And let's see, does it change color? Does it indicate the equivalence point? Is the end point coinciding with the equivalence point? Yes, it is. So can methyl orange be used as an indicator in this pH titration curve? Yes, it can. A few things that you must understand regarding the pH titration curves is where to start from. If it's a strong acid, the pH will be very low in the flask. And as we are pouring an alkali, the pH will very gradually rise. And at the equivalence point, the pH will suddenly change to a very high pH after the equivalence point. And because we had a strong alkali, the pH will end up on a very high level around 12 to 13. So what if I would have had a weak acid and a strong alkali, and the indicator would still be methyl orange? Now let's see what happens. See, I have a very weak acid, so the starting pH is not very low, but it gradually increases as an alkali is being added. And let's see what happens. See, the methyl orange has already changed color and it has already become yellow because the pH is nearing 7. And this is where the equivalence point is. Did the methyl orange change color at that particular instant? No, it has not. It already changed color. So methyl orange is not a suitable indicator for a weak acid and a strong alkali titration. Okay, now let's change the indicator and go for phenolphthalein. And let's see what does it tell us. So phenolphthalein is colorless initially in the acid. The pH will eventually start to rise. I'm adding a strong alkali to the burette. The pH rises. The phenolphthalein has not changed color. My indicator is still colorless. And this is a point where I have reached the equivalence point, and that is the exact instance when phenolphthalein has changed color, and it is a very good indicator for a weak acid and a strong alkali solution, a strong alkali titration, because it changes color exactly when equivalence point is reached. These indicators, they change color as per pH. So the changing pH, the pH at which phenolphthalein changes its color, coincides with the equivalence point, and phenolphthalein is a very suitable indicator for a weak acid and a strong alkali titration. Continuing with the same trend, what if I wanted to use a strong acid but weak alkali. Let's take ammonia for example. And if I would have done that with phenolphthalein, I hope you people are noting down the important indicators with different combinations of and different strengths of acids and bases. See now, because I have a strong acid, the pH is very low and it is gradually rising with the addition of ammonia. The solution is colorless because there is phenolphthalein in it. And you see, the at the equivalence point, the phenolphthalein did not change color because that high pH was not achieved because I had a very weak base. And phenolphthalein will change color later on after I've passed the equivalence point. So it will not ideally indicate when have I reached the equivalence point while I am performing a titration, and hence for this one phenolphthalein is not a suitable indicator. What if I would have gone with methyl orange? Strong acid and weak base. Now let's see. The pH at which methyl orange changes color is around 3 to 5. So let's see whether methyl orange is a suitable indicator for us while we are performing the titration of a strong acid and a weak alkali. Yes, you see from orange it turned yellow at that very instant when equivalence point was reached. So methyl orange is a very suitable indicator when the acid is strong. Phenolphthalein is a suitable indicator when you have a strong alkali. What if both are weak? What if both are weak? Let's take acetic acid and ammonia. And my solution is already yellow. Yes, this simulation does not provide support for that, but we generally tend to use bromothiamol blue for a weak acid and a weak alkali combination. So I hope this would have been clear. Methyl orange when a strong acid is involved, phenolphthalein when a strong alkali is involved. If both are strong, both indicators can be used, and if both are weak, then we generally go for bromothiamol blue.